do balbo do bar.
Finish your lunch. Alright, so today I'm going to talk a little bit about Filepoint and then the growth of Filepoint, how it's being powered by a couple of the features that we've been working on for the past few months and we're going to work on in the future, which is the programmable storage and the chain scalability. So guys, I hope you guys know what Filepoint is, and we've been around after mainnet it's only been three years. In these 3 years, there's a lot of milestones being made, and a lot of issues that we discovered, and then we talked to a lot of builders to find what improvement that we need to make on the Filepoint network and what we need to bring onto the Filepoint network. And eventually we're delivering step by step, reaching to more powerful Filepoint ecosystem to support builders to explore any possibility to build applications on Filepoint. So I hope after this session, you guys can learn what you can do on Filepoint and what features it's on. And potentially, if you're interested, you can grab a couple of the starter kit that we have right now, and then try your idea at the East Global Hackathon during this weekend. We're also sponsoring that event, and then a couple of prizes to grab if you want to try how to use Filepoint as storage, IPFS or FVM. But let's get into it. And everything has to start with the Filepoint master plan, because that's the way of retrieving the growth of Filepoint, and then how we're building a Filepoint step by step, and then why we have a certain different priority at different stage of the network growth. So this vision has shared by couple years, 2 years ago, and so for starting from 2020, that when Filepoint mainnet launched. We start working on our first step, which is building the largest decentralized storage network. And in that year, we mainly focused on getting a lot of storage provider onboarded on Filepoint, and then have the decentralized storage ready so we can start onboarding data. Right, there's a lot of progress being made, and we have a couple of the node implementation to support different scenarios, like Lotus as the implementation for the reference. And we have Venus to focus on providing the faster and the more efficient tools for storage provider to use. And we have Forest focus on visualizing the tools, visualizing the data onboarding, the nodes of operations for a Filepoint network. And in that year, I mean, if you look at the Filepoint Explorer, you can know that the storage capacity on Filepoint is huge right now. And pay attention to the raw storage, because we have another indicator which is adjust storage capacity, which is changed by contribution of Filepoint Plus, which is encouraging to onboard more useful and valuable data on Filepoint. So on that size, we're already reaching almost like 12 gigabit, which is a huge storage to onboard a lot of data. And if you want to compare with how the centralized storage grows, it took a decade for the centralized storage to grow that size. And then after that, we have to focus on to utilize those storage to onboard the valuable data for humanity onto the Filepoint network. And then the team is working on like data onboarding and then building a lot of tools like Singularity, NFT storage, Web3 storage, Astra to help onboard those data onto Filepoint. But is that enough? And then how we can fully take advantage of the data on Filepoint, right? If we think about Web2 and then all this platform like Facebook and WeChat, they have a user and they have a lot of data behind the user. But we have to do something around this data to be more useful to use those humanity data. That's why we have to bring the computation to the Filepoint and then make sure that the data on Filepoint is not just accessible, but the metadata of those data, the value of those data is accessible from the user, from end user or application. And that's the third step we're working on, is bringing the computation to the data. And how we're doing this? I'm going to mainly focus on a few cool products that we're working on. And this will make you guys have a better vision on like how each of those products is powering their vision. So if you're familiar with all the tools in here, the IPFS, I think Hugo is explaining a little bit, indexing, content indexing But as the layer structure powering everything, IPFS is the file system, decentralized file system supporting the Filecoin and FVM. So in that, built on top of IPFS, we have a Filecoin which brings in a sensitive layer to making sure that your data stored on IPFS will not lost if your data is not pinged on IPFS, if that node is shut down in the IPFS network. And with the data stored on Filecoin, and the data are stored securely because it's stored by making a storage deal with storage provider on the network. So all these deals, approves are generated by storage provider and has to be posted online to be able to verify on chain. So which means your data will store safely and secure on the Filecoin network. So above that, we need to provide the ability to compute over your data, to compute over the status of your data. For example, if your data is stored securely and safely, that can be used as like for the data insurance, to making sure your data is accessible, and also to be able to verify the usage of the data and then the ownership of the data to be able to generate value if you want to sell or sell the usage of those data. And then about that, obviously, I think if people are building on the application, you will run into issues. For example, it's too slow to wait for transaction to be processed for DeFi project. It's not possible to have the all game deployed on the blockchain and then having all each steps processed on chain through smart contract. It's impossible. And also, if you store data on Ethereum, if you store data on Solana, how is it possible to accept access from Filecoin? All these things are another level. We have to scale Filecoin to be more efficient to support applications like DeFi, like gaming, and also to be able to cross access to different chains. So your storage and then your logic, your computation could be at the same level and be accessible. And hopefully that could be achieved by IPC. I think I explained too much and then this slide covered all that already. So that's how you can vision a different component on this process will help, right? Like the IPFS Filecoin supporting the storage layer, and then we bring on the FVM. FVM bring the smart contract capacity to Filecoin, so we can access the status of your storage on the Filecoin using smart contract. For example, using smart contract to monetize the status of your storage, and then to reduce the status and be able to like verify the access, verify the storage, and then we sell the access and be able to bring like another possibility like data insurance and data down into the Filecoin. And then once we're building our Filecoin to the data DTF level, and we need to scale, more. So that's why IPC can come in. I will explain a little bit more on what is IPC later, but let's focus on FVM first, because that's first of my focus on programmable storage, like how FVM can help Filecoin reach to a wider ecosystem and having more possibility to build on Filecoin. So as the first thing of Filecoin, all we know is the storage, right? Like we store data through making a deal with storage provider, and then without FVM, all this process all happen off chain. So you have to bridge to a storage provider and then to make a proposal with them, store your data on certain terms, like how long you will store, how much you're willing to pay. And there's a lot of off-chain process going on here. And also, there's a lot of process that cannot be handled on chain to be able to verify, like the aggregation. And if storage provider grab data from all of you guys here, and then to put together to be able to store on Filecoin, which is the sector size, 32 and 60 gigabit. And if they do it off-chain, and it's not on-chain verification on if your data is stored on that sector or not. And all this will be achieved when FVM is on there. We'll be able to put the aggregation process which is grabbing all the files from each of the users and then putting into one size intersector and then be able to generate those proof on chain in the smart contract, which we call on-chain aggregation. And then why we need to do that is it will bring the storage towards the more decentralized level, right? We have a PowerPoint that we're aiming to provide the storage, to provide a decentralized storage. But if some of the process happening off-chain and you not be able to verify those, in a certain way it's still centralized. And now with FVM, we can build all this aggregation and then inclusion verification on-chain and then be able to propose that storage deal on-chain. So the storage clients, storage provider, or the user to be able to track that process completely on-chain. There will be a more transparent and centralized way of doing storage. But obviously, that will bring some of the downside of the efficiency and then how long you need to wait to get on-chain, how to verify. But it's just a more decentralized way to do it. You can always still have the other option of onboarding your data through a storage provider off-chain. That's another option. But with FVM, all this become possible. And also, I hope you guys have a background understanding of how Filecoin works, right? Like, if you make storage deal on chain, one of the attributes you have to make on the turn is how long you store and how many copies you want to store on the Filecoin network. For example, I want to store my YouTube video on Filecoin with 3 storage providers, and then they're gonna last for 1 year. So there are a few things that get really important. I want to store 3 copies, and I want to store for 1 year. So all this has to be modified on chain. And currently, it's also taken care of by the off-chain part of a storage provider doing it. But we can also move that on chain and then through smart contract to make it a more programmable way that write a smart contract to be able to modify the status of your storage deal. The status including, is it real that 3 copies of my data are stored? And if my data is have something wrong with the storage sector, and then if a storage center is done, and then is that possible to be able to help me to repair this data? Or when it's reached to 1 year, I need to renew, making sure my data will be stored on Filecoin permanently, like storage, and I have to do renew after 1 year. All this can be done on chain right now through the project that we're building is ROS, which is renew, repair, and replication as a service. And then it could be hosted with aggregator that I mentioned earlier. And then it could be completely hosted by a third party. But this is also making sure that we use FVM to bring the more programmable way of managing your storage deal on chain. So with all this possibility, and that's just all the features that FVM will bring around programmable storage. So if we take an example to understand what exactly it means and how we can build things on Filecoin, this is a good example of DataDAO. And we have a DataDAO starter kit, which you can, if you're interested to learn and then build, you can grab the starter kit and then add in the more feature. But let's first understand what is DataDAO. First is data, right? The second is DAO. DAO, I assume everybody understands because now, like DAO, the concept is everywhere. But basically, DAO will be a distributed member of managing the same thing, the voting, executing certain things that when they reach the agreement, right? Like one of the things that they manage here is data. Right, we just use the DAO, a group of members who care about how to accumulate certain data and how to use this data to be able to generate value. So, for example, a group of members will have, if they have enough resources to collect data, they will store those data and then secure them on Filecoin. And if those data could be used to generate value, And they can also build on how to use this data, how to maybe sell this data to users, and how to use those data for the decentralized computation, for the machine learning and the AI. But in order to document those data, they have to be able to access the status of those data stored on Filecoin, and then be able to verify, to be able to use it, and then certify other entities to use this data. All these are going to be achieved through the smart contract developed on Filecoin through FVM. So that's the basic concept of DataDAO. If you are interested in having an idea of a group of people managing the data and then use the data to generate value, this value could be from by reselling it, by getting more benefit from storage provider. And you can just grab the starter kit and then try the concept, maybe build it for the East Global events. And that would be the ideal scenario that we'd like to see. And also, we have a very close collaborator, is Lighthouse. They fully implement all those programmable storage features on Filecoin, like the ROS that we mentioned, and then also store data through FVM completely on-chain. So if you're interested in using, and then to actually try the way of using storage through the programmable way, you can try the Lighthouse. They have a pretty good document to explain how to upload data through smart contract on FVM, compared with how to upload data using the SDK, which is directly making storage deals with the storage provider. So if you're interested, you can go, and they have two sections. One is how to use the Lighthouse SDK. Basically, just import your SDK, and then says store my data. And then another is you have to interact with the smart contract. And then the smart contract has the function of submit and then register to rest. All this will be recorded and executed on chain. Okay, so that's the first part I want to talk about is programmable storage. With FVM bringing the smart contract, bringing the virtual machine environment to Filecoin. There's a lot of features can build on through smart contract, and then taking the advantage of the data and then status of the data on the Filecoin. But when we start building things on Filecoin, and we have a lot of collaborators, the builders keep coming and ask questions like, for example, Filecoin block time is 30 seconds, and then the finality take the best scenario, 5 epoch, 10 epoch, it's going to be like a couple minutes. But currently, the most project built on Filecoin is D5, that's resolve the problem for SP. But when they come to you, this is slow. Like getting the confirmation and then getting the finality on Filecoin is too slow. How are they going to solve it? So they've been complaining. That's one issue that we're hearing. And then the couple of the other builders, like we are having a decentralized computation network. They are computing the data stored on IPFS and Filecoin in another decentralized network, and they want to have a more customized chain to be able to isolate the process of storing data and then executing the data. So they want more customization on the chain. They want a different environment, and they want the feature to be able to cross to other chain like Ethereum. But on the Filecoin, it's not possible, and we cannot do it. And also, we have like people in the Filecoin ecosystem dedicated to build the storage and build the retrieval for the storage, which is we have a Titan network, and then they are building the retrieval. The CDN, decentralized content addressing network. They also want to have their own chain to be able to manage the retrieval process and to manage the payout for retrieval. And so, but all this combined on the Filecoin, mixed with all the proof generated for storage, and all the transactions for the DeFi, and all the transaction with the retrieval. I mean, that's a lot of process in the same chain. If you're thinking about 30-second block time, and that's super unrealistic. With all this issues coming from our partners, from our builders, that we have to think if is another good way that we have to scale Filepoint to be able to better support those builders, regardless if they are building on the storage or they are building on the track of the blockchain. So that's how we bring the IPC, which is interplanetary consensus. So this diagram actually really easily explains what it is and how we use it to scale the Filepoint. So it's to understand it's easier. So it's from horizontally scale on the Filepoint. What does that means is we can use IPC the same way that we use substrate, that you can bring up a subnet on top of a rootnet. So currently we're building on top of Filepoint. So Filepoint will be acting as the rootnet. And then you can build your subnet for certain features on Filepoint as a rootnet. And then the example here is the database, right? Like we can build a subnet handling all different data set, data store on Filepoint. And then also building another layer of subnet if there's a use case requiring different settings. And then another example is game. Right, we can just isolate the storage layer for Filepoint, and then the business logic process layer on different subnet, and then you can build it on top of it as a hierarchy tree. And also, the same as other layer 2 builders, it will share the safety and the security from the Filepoint because we're doing the like bottom top down and bottom up security checking through the validators or through the relayers on different networks. So that's the first advantage. The second advantage is also isolate the computation storage on Filepoint with other blockchain, but at the same time also be able to access the storage layer on Filepoint. So, which means think about Ethereum, like Ethereum as the process of all the transaction finalized. The same on Filepoint. On Filepoint network, we are mainly focused on the storage, storing data, processing all the verification data, and then putting all this logic on the subnet, but be able to make sure all the subnet can access the storage data on Filepoint and access the status of those data on Filepoint. And then it's also how we have to make it more modularized and then be able to customize based on different projects need, like what lily pad is need and what the Tidance is need. So we make IPC more modular, so you can configure a different token model, and you can be able to configure a different consensus. You can use tandeming consensus. You can use the POS, POW consensus in the future. And then we also have to provide a different environment, and that is based on FVM. If you know how FVM is implemented, I'll extend it. So FVM is a Wasm-based runtime environment. Which, if you understand Wasm, so a lot of the language can be compiled into Wasm, like Rust, JavaScript, as long as you have a compiler that can compile into Wasm and to be run, which means it supports multiple runtime. And currently we support EVM, so FVM is EVM compatible. But in the future, it's very easy to be able to support other runtime. And then that's also another features that like the IPC can be modularized and customized to support different needs and different scenarios. So that's why we bring IPC, and that's how IPC will bring and what's the benefit it will bring. So, but how you're able to do it, and I already explained the FVM part, which is make it more like make it support multiple runtime environment. And also we have an IPC that has the consensus layer, consensus module, so you'll be able to configure and use different consensus. So now currently we're working on the Filepoint, we supported Filepoint Lotus, and we work on the tandeming consensus, which is Fendamine, which is more like a BFT consensus, a couple of validator rich to consensus. And then we'll be able to configure the block sign, just process 1 second for block sign, and it's super fast compared with 30 seconds on the Filepoint mainnet. And if we're still working on the IPC, and currently we are aiming to release the version, a tested version by Thursday. So we're having an IPC event on Thursday, and then we're going to be an announcement on the testnet. And so that's the first step that builders can come in and then try the testnet. This testnet is an anchor to a Filecoin testnet. What does it mean? It means the token has to come from Filecoin. So you have to get your token from Filecoin testnet into this IPC subnet because there's like hierarchy infrastructure. And then you can be able to access those tokens and then build the application on that to enjoy the fast finality and the fast block time. So we are expecting and encourage people to try, and it depends on what you're building. If you're building a network, if you want building a network, you want to use the Filecoin storage and build something around Filecoin storage, and you probably want to learn how to deploy a subnet, how to deploy a subnet anchored to calibration. And if you are a like DeFi builders or builders want to build on top of Filecoin, but you don't want to handle the slow finality and then the complexity of building the storage, and you can just try to deploy a small contract on our IPC subnet, which is Mycelium, and it's already ready. But if you want to try, and then you can wait a little bit until Thursday to enjoy the more stable version. So if you're interested, there's the QR code to get to the document page. And if you don't get it, we have the docs IPC space, and you'll be able to learn what is IPC is. But most important is try this two quick start tutorial to learn how to deploy a subnet, or to learn how to connect to that subnet and deploy a smart contract on it, and you can feel it. I mean, if you're building on Filecoin and you see, that will resolve your pain. Okay, I think that's all from my content. And if you all want to learn more about programmable storage or IPC, and come to our events on Thursday, which is at the Swiss Hotel, which we have Protocol Lab events starting from 9. And come here to talk with the FEM team. Matt and Mio is here. And then we also have other IPC folks on the events can tell you more about the future of IPC and then the roadmap and the vision. So if you're interested, come to learn and chat with us.
Constantinople, get the works.